Now let's try to find out the derivative of tan inverse x. Just like in the previous video, we find the derivative of sine inverse x and cos inverse x, and we learned how to use the result of those inverse functions to find out the derivative of other trig functions. All right, such inverse trig functions. So let's now find out the derivative of tan inverse x. So let me suppose this is my function y equals tan inverse x. So since this is inverse, so I can take another side, so it will be tan y equals to x. Now since tan has the angle y, so let's try to differentiate both sides with respect to y. We get tan y, right? It is tan y. So differentiating with respect to y, we'll get same here, dx over dy. And now derivative of tan y with respect to y will be sec square y, and this will be same dx over dy. And you know one thing, we had learned that sec squared theta plus tan squared theta equals to 1. So what we can write here, that sec squared theta equals to, in the early trigonometry we had learned that sec squared theta minus tan squared theta equals to 1. So from here what we can write, that sec squared theta is equal with 1 plus tan square theta. So here instead of sec square y, what we can use 1 plus tan square y. Alright, so we can use here now 1 plus tan square y equals to dx over dy, and further 1 plus tan square y. What is tan y? Tan y is actually x, so I can write here x squared equals to now dx over dy. So further if we rearrange or find the reciprocal of this, then we'll get dy over the dx equals to 1 over 1 plus x square. Alright, so finally what we find, the derivative of the tan inverse x is equal with 1 over 1 plus x square. So here what I can conclude, that derivative of tan inverse certain angle like x is equal with 1 over 1 plus angle square. Here x is the angle, so that's why x square. So now we can use this result just like an identity, just like the formula, to find the derivative of other stuff, right? So let me take an example. I will try to find out the derivative of a function like y equals to, suppose, tan inverse anything you say, like 3x plus 2. all right, this is our function, and let's try to find out the derivative of this using this formula. How simply we can find out. So dy over the dx will be now equal with derivative of tan inverse 3x plus 2 divided by dx. Alright, we cannot differentiate tan inverse x 3x plus 2 with respect to x directly. We need to first differentiate any trig ratio with respect to its angle, and here angle is 3x plus 2. So we're going to differentiate with respect to that. So derivative of tan inverse 3x plus 2 with respect to its angle 3x plus 2. Since we have added this from our side, so we need to find out the derivative of that quantity also, 3x plus 2 with respect to x. So finally we are differentiating both sides with respect to x. Alright, so what will be the further result now? So derivative of tan inverse angle with respect to its angle. Derivative of tan inverse angle with respect to angle is 1 over 1 plus angle square. So here also 1 over 1 plus angle square, and angle is here 3x plus 2 whole square. Alright, and then times the derivative of this 3x plus 2. What is the derivative of 3x plus 2? So x, derivative of x is 1, and 3 is the coefficient, will come outside just 3, and derivative of 2 is 0. So no matter to write, no reason to write that, just we can just write 3 over 1, this is 1 plus 3x plus 2 whole square. This is our derivative, required derivative of the given function. Alright, so this is how we can find out the derivative of the tan inverse function using the formula. But if you don't want to use the formula, you want to do in this this process, then you can again find out. Let's try to do our example. Okay, suppose I have a function y equals to tan inverse suppose 9x square plus 2. Okay, so I want to find out the derivative of this. So what I will do, I can now write that tan y is actually 9x squared plus 2, because tan is here in inverse. In another side if you'll go, then it will be positive. So tan y, and here is dx squared plus 2. Now I'm going to differentiate both sides with respect to y. So what I will get, d tan y over the dx will be again here d 9x squared plus 2 divided by dy. So what I will get further, tan y it is. So now derivative of tan y will be sec square y, and derivative of 9x squared with respect to y will be 9 to the 18x times dx over dy, and derivative of 2 will be 0. So what is sec square x? We can write that is 1 plus tan square y, that is 18x times dx over dy. So further tan y, and what we know that tan y is actually 9x squared plus 2. So 1 plus 9x squared plus 2 whole square is 18x times dx over dy, and we need to find out the dx over dy. So what is our dx over dy? Dy over dx, sorry. Our dy over the dx, or derivative of y, our function this, alright, derivative of this y with respect to x will be, just now I'm making the reciprocal, so it will be now 18x over the 1 plus 9x squared plus 2 whole square. Alright, actually I write this dy here and dx here, and 18x is as it is, and this whole quantity went to the downstairs here. Alright, so this is how we need to find out the derivative of tan inverse functions. I hope you understand to find the derivative of tan inverse functions, and if there is any more confusion or any doubt in this explanation, then please feel free to comment just below this video. I really appreciate your some of your feedback. I becomes really happy when I get something from your side. So please don't forget to subscribe the channel, and don't forget to comment the video. Catch you in the next video with next problem. Goodbye.